Good morning to all of you. Today we are going to study the unit processes and give its to importance. So this part is near to completes, and I think it will be completes after some lectures. So this is regarding the dyes, and the unit process are used for the dyeing process. In that process there are the two important points is also that we have to be mentions. So the questions will be asked what are the unit process and give its true importance. So unit process are a single step chemical conversions taking into considerations the unit process like nitrosations, deazotizations, oxidation, etc. introduce chromophore like NO2, NO, N triple bond N, C double bond O group etc. in the molecules. The unit processes like halogenations, ammonolysis, reduction, oxidations, hydrolysis, alkylations, sulfonations are introduced in the oxochromes. The unit process like cyclizations, unit process like cyclizations, condensations, aromatizations, azocouplings, etc. are used to convert the intermediate into the dye stuff. Importance of the unit processes. The unit process are used in the conversion of the primary organic chemicals into the dye intermediates. Thus, the unit process are necessary for the functionalizations of the primary organic chemicals. Oxochromes are necessary to intensify the color of the dyes, also increases the dye fiber effect affinities. Next is the what is the nitrations, what is the function of the concentrated H2SO4 in acidic mediums. So in the nitrations nitrations means addition of NO2 groups to the nitrations. We know that when there is a suffix like ATIONs there means that suffix compound is going to be added in the main structures. So this is nitrations. So nitration reactions are done on the, if it is done on the benzene ring, then there is substitution reactions. It replaces the hydrogen atoms by the NO2 groups. So for the nitration reactions, we know that in the nitration reaction we use the nitrating mixtures. We well known that the nitrating mixture is the concentrated H2SO4 along with the concentrated HNO3. This is the nitrating agents. So these nitrating agents used for the nitration of the benzene ring. So it is the process of the introductions of the nitro groups, that is NO2 groups, into the aromatic nucleus. Nitration is carried out by the action of the mixture of the concentrated HNO3 and the concentrated H2SO4s. So the starting material plus HNO3 concentrated on the arrow is the concentrated H2SO4 gives the NO2 plus H2O. The function of the concentrated sulfuric acid. The function is that it is dehydrating agents. and absorb the water formed during the reactions and thus drives the equilibrium forward. Two acids react and generate the nitronium ions, which is the actual nitrating species. Sulfuric acid also forms a conjugate base, which will help in the removal of the protons and restoring the aromatic rings. What is the dye intermediate? Dye intermediate are functionalized primary organic chemicals. Example is the aniline, nitroaniline, resorcinol, sulfonilic acid, naphthol, naphthylamines, and anthraquinones, BDone acid, and hydrogen acid, etc. The dye intermediates are the derivatives of the primary organic chemicals in which functional group like dye intermediate are the derivatives of the organic chemicals in which functional group like NO2 diNO2s are used. Next is the explain Armstrong theory and its limitations. The Armstrong theory and its limitations. Armstrong theory established in 1888. The color of the compound is due to the presence of the cunoid types of the structure ortho and para. Cunoid rings is only a combination of the chromophore, that is C double bond C and C double bond O. Thus the Armstrong theory can be considered as the extension of the chromophore theory, that is orthobenzoquinones and orthoquinoid structures, parabenzoquinones, paraquinoid structures. When the naphthalene is present in the benzoid form, it is colorless, but it is sodium salt can assume quinoid structure, hence it is a pink colors in alkaline mediums. So the naphthalene is the colorless compounds react with the NaOH, sodium hydroxide. Naphthalene having the phenolic rings attached on the carbon atoms. Naphthalenes react with the NaOH, then there is a replacement of hydrogen atom of the phenolic group by the sodium, and it is formed the sodium salt and it having the pink colors. Same for the paraquinoids is there with the structures. There is also OH group which acidic hydrogen is replaced because NaOH is the strong base. It abstract the protons of the NaOH groups and replace that hydrogen by the sodium atoms. So paraquinoids compounds. Next is the limitations of these compounds. So what are the limitations of these compounds? The immunoquinones and the diimmunoquinones have the quinoid structure, yet they are colorless. There are large number of the colored compounds, but they cannot be represented by quinoid structures. That is benzene ring, N double bond N, benzene ring, azobenzenes. The immunoquinone and the diimmunoquinone has the quinoid structure, but they are colorless. There are large numbers of colored compounds, but they cannot be represented by the quinoid structures, that is benzene ring attached with the nitrogen double bond N, azobenzene groups. Next is to define the terms chromophores again. So the chromophore are the unsaturated functional groups which are responsible for the absorptions of the UV radiations. Examples of the chromophoric group is the C double bond O, comma N double bond O, N double bond N, C double bond C, NO2 are the examples of the chromophoric groups. Explain the benzene is the colorless, whereas the nitrobenzene is the pale yellow, whereas the para-nitroaniline is the dark yellow. The benzene does not have the charge resonance structure, and it is more over the molecules is the symmetrical. Molecule require higher energy for transition, hence it absorbs the UV light and it is colorless. Nitrobenzene has a charge resonance structure and dipole moment of the 4.2d, hence the absorption extends into the visible regions and it has the pale yellow colors. In paranitroanilines, there are large number of the charge resonance structures. It strongly absorbs the visible region and hence there is a dipping of the color that is dark yellow. The two extreme resonance structure of these compounds are their resonating structures. What is the sulfonations and what are the reagents used for it? Sulfonations means sulfur SO2 groups is additions. SO3H group is added. Sulfonation is the introduction of the sulfonic acid group, that is SO3H in the aromatic ring. The sulfonation can be carried out by the following reagents. One is the concentrated sulfuric acid oleum, which is a sulfur trioxide dissolved in the concentrated H2SO4 sulfuric acid, and the sulfur trioxide complexed with the pyridine or other Lewis base. The concentrated H2SO4 generates SO3, which is the actual sulfonating species. It also acts as a self-catalyst and the dehydrating agents. It forms the conjugate acid S3O plus and the conjugate base HSO4 minus. This is all about the sulfonating agents and the sulfonating reagents. So this is all about the today's lecture of the drug and dyes. In these topics we have covered the part what are the unit process, give its true importance. In that we have studied the unit process. The unit process are the single step chemical conversion. The unit process like nitrations, nitrosations, deazotizations, oxidations, etc. Introduce the chromophore like NO2, NO, N double bond and C double bond group. It is in the molecules. The unit process like halogenations, ammonolysis, reductions, oxidations, hydrolysis, alkylations. Sulfonations are the introduced in the oxochromes. Unit process like cyclizations, condensations, aromatizations, azocoupling, etc. are used to convert the intermediate into the diester. And the important points of the unit process are used in the conversion of primary organic chemicals into the dye intermediates. The unit process are the necessary for the functionalization of primary organic chemicals. Oxochromes are necessary to intensify the colors of the dyes and also increases the dye fibers affinity. Next is the what is the nitrations and what is the function of the concentrated H2SO4 in the acidic medium. In the nitration, it is the process of the introductions of the nitro groups into the aromatic nucleus. Nitration carried out by the action of a mixture of the concentrated HNO3 and concentrated H2SO4. HNO3 and H2SO4 gives the NO2 as the product. Function of the concentrated sulfuric acid. It is a dehydrating agent and absorbs the waters formed during the reactions and thus derive the equilibrium forwards. The two acids react and generate nitronium ions, which is the actual nitrating species. Sulfuric acid also forms the conjugate base HSO4-, which will help in the removal of the protons and restoring the aromatic ring. What is the dye intermediate? The dye intermediate are functionalized primary organic chemicals. Example: aniline, nitroaniline, resorcinol, sulfonalic acid, naphthols, naphthylamines, anthraquinones, BON acid, hydrogen acid, etc. Dye intermediate are derivative of primary organic chemicals in which functional groups are present. So this is all about the today's lectures. Remaining part we will cover in the next lecture. Thank you.